Hello, everyone. Welcome back to SAT Math Question of the Day with Professor Emeritus Seth Chaiken, University of Albany, and Seth's brother, Joel Chaiken. We're here to help you learn how to go over how to approach SAT math questions. Here we have a math question from the calculator section, although something tells me you're probably not going to need a calculator for this. It's a little bit of a word problem. Okay. So, last week, someone worked 11 more hours than Angelica. If they worked a combined total of 59 hours, how many hours did Angelica work last week? Oh, Angelica worked fewer hours, right? So isn't it just 59 minus 11, which is 48? But you got to be careful here. You got to be careful. Can't be that easy, right? Raul equaled 11 plus A. Okay, if they worked a combined total of 59 hours, so R plus A is equal to 48. Maybe how many hours did Angelica work? I don't know. Something tells me I should just be careful here. So Angelica is equal to 48 minus R. So, we care about Angelica's hours, so we solve for R. R is equal to 48 minus A. So if R is 48 minus A, then 48 minus A is equal to 11 plus A, and I'm getting a different answer, which makes me a little concerned. We add A to both sides. We get 2A is equal to 37. Well, that can't be right.
Yeah.
Something's going wrong here.
You're going down the rabbit hole.
Yeah, something's going wrong here. Yeah.
You've lost your way down the rabbit hole.
I think the answer is just 48. What do you think, Seth?
Well, I think we should start afresh.
I agree.
How about this? Start afresh and do it using algebra. And then I'll do it using common sense.
Okay.
You went down the rabbit hole.
Yeah, apparently I did. Yeah, because it can't be that hard. Okay, last week, I'm going to be careful now. I'm going to translate English into math. Raul was worked 11 plus A. Raul, the R stands for Raul's hours, A stands for Angelica's hours.
Yeah.
If they worked a combined total of 59 hours, so isn't that R plus A is equal to 59? How many hours did Angelica work? You would think this would be the way to do it. Now you want to
eliminate. You're interested in Angelica.
You want Angelica, so
eliminate.
Seth,
eliminate R.
I know. Seth,
okay.
Seth, please. Then you're gonna have you'll do it. And you want Angelica. So R is here. So we say A plus R, which is 11 plus A, is equal to 59.
Yeah.
We subtract 11. We get 2A is equal to 48. So A is equal to 24. Wow. Okay. So before I was wrong, right? I did it too fast, didn't I? But I had an intuition that something was wrong when I did it that fast, right? Remember I said,
right,
go back to the video. I said
you were tripping into the rabbit hole.
Something said, so watch that, right? It can't be that easy. This will be a this will be a fourth grade question. And I had a bad feeling about that. And then I went into the 37.5. Thank God when I went into that disgusting thing, I got a fraction. I got 37 over 2, something weird. And then I just started from scratch, which is the way to do it. See, this is how you approach SAT math questions. If it's too easy, it's suspicious. You make a mistake. You get 37 over 2. Stupid answer. You start again. And then eventually calm down, take a breath, do it. You get the answer. Okay, so that was a good thing I made all those mistakes. Yeah, that's how you approach these problems, and that's what we're going to do.
So if you feel yourself tripping, and you're filling your workspace with stuff that doesn't make any sense, and it looks like a pretty easy problem, then a way to approach it, a good way to approach it, is say, "Hey, I've tripped up on this. Sorry, Charlie," and start afresh.
Right.
With a start afresh and be a little bit more careful, and you get right to the answer.
That's exactly the whole point. You see, when we're doing these questions live, this is exactly how you approach a prompt. Now, Seth, I would love to know how to do it more, like, you know, the way you want it. Yeah, like the cool.
Okay, let's do it like a picture.
A picture.
So Rawl worked more than A. Rawl worked more than Angelica.
Okay.
So we think of the amount of work that Angelica did as the length of this rectangle. Rawl's rectangle is a bit longer than A's.
Okay.
Right? And then we're interested in A, in how many in the width of A. So what we're told is how much more R is than A is 11. So there's 11 units of work between here and here. So you slice off the 11, and then you have to use the other information, the total. The total is 59.
Okay.
So the total is 59. That's all this. Sorry, all this stuff is 59. You slice off, you know that this much is 11, so you slice off the 11. 59 minus 11 is what's left. Well, half of it is A's work and half of it is R's work. So, so we have to do arithmetic. 59 minus 11 is 48. So 48 is the total of all the work done, say, represented by these lengths. 48 is this is this length plus this length, so half of it is A's, which is 24.
Right. Yeah.
Another way of thinking of it is imagine that Rawl and Angelica start working at the same time. They work together until Angelica stops, and Rand works 11 more hours. So the same picture. This shows their schedule. The total is 59. You lop off from the total the 11 when Rawl worked by himself. You're left with 48 hours in total. But the period of time during which Rawl and Angelica work together, since they're working together, the amount of stuff they accomplished was 48 hours worth. Each of them did 24 hours worth.
Yeah. These work problems.
So we did not do it using algebra, but using thinking about the quantities, how much thinking clearly about what the quantities were.
Yeah, if you use algebra, it's almost a it's actually a two equation to a known problem that you have to solve through substitution.
Yeah. However, well, people they teach how to do it with you could do it with one equation. Sorry, you could do it with one unknown, but it's all it'll all work out equivalently.
Right. Yes.
I think it is clearer in explaining the logic to use two equations and two unknowns.
Exactly right.
That's an advantage of two equations and two unknowns. You don't have to remember what an intermediate expression is, like R minus 11 is the intermediate expression.
Or no, isn't the immediate expression the it's not 59. It's R minus 11, right? That's where I messed up originally. Yeah. So what would be the
R plus 11? It's R minus 11 equals A. Yeah.
What was
Okay.
the? Now I was thinking, what was the question? What would be the question that would lead to 48? Wouldn't that be that they work a total of 59? Wait, so what would that
48,
question?
48 would be the amount of accomplishment measured in hours of accomplishment that were accomplished during the periods when both of them were working.
Right. No, but if you wanted 48 to be the answer to a question,
That would be how much, yeah, uh, how many hours uh, did each of them work when they were working together?
okay, but no, okay, so but forget that
No,
together
sorry,
thing.
sorry. No, yeah, no. What is the total amount of hours worth of accomplishment did they accomplish during the period when they were working together?
Right. Okay, that would be the answer to 48 to this problem, to
Yeah,
sort of this
yeah.
problem. But what would be the answer to 48 for a fourth grade problem? What would
I
be
don't know.
the answer to 48 would be
Okay,
59
maybe
minus 11.
a second grade problem.
The
A
second
second
grade
grade
problem
problem.
would be that something is 59 and you just take 11 away from 59 to
Okay,
get
here's
48.
let's look up. A second grade problem would be uh uh Roll and Angela work together for let's say Roll and Angela work together for 24 hours. Uh how much how many hours worth of accomplishment did they accomplish? So you add 24 and 24 and get 48.
Oh, no, I'm looking at a problem where the answer would be 59 minus 11. You have 59 apples and you take 11 away. How many apples do you have? You have 48 apples.
Yeah, yeah.
So what would be the work problem in that? That
48.
they work together, they work to
Well, yeah, sure. We have Oh, good. That's a good question.
Thank you.
And Angela, Roll and Angelica have 59 apples together.
Right. Yeah.
Uh, Roll has 11 more apples than Angelica. He gives away if Roll gives away 11 11 apples to yeah, right. If he gives away when he gives away 11 apples, then they have the same number of apples. They each have the same number of apples. How many apples do they have together when Roll gave away his 11 apples?
Wait, what can't isn't it just Roll and Angela have 11? Oh, Roll and there are 11 apples on the table. Oh, wait. Oh, wait. So it's not simply Roll and Angela have a 48 of 40 to 59 apples and Roll has 11 more apples than Angelica, so that
Yeah.
means that oh right, that gets complicated, right? They
Well, the
have
question is, no, say analogous number of apples each one has is analogous to how many hours each one works.
I'm just dying to know. Can't we make up a really simple third grade question where the answer is 59 minus 11? It's killing me.
Okay.
It's killing me.
The answer is 50, so you have to have 59 and 11.
Yeah, so in other words, you have 59 things, and one
Yeah.
person has 11 more than the other. So doesn't someone have 48? No. Oh, that's right.
The
So
two of them, yeah.
Oh, it's two of them. Yeah, so it's a complicated
Yeah.
question, right?
So let's see. Roll has
Oh, because they have them
11
together.
more apples than Angelica.
Oh, and then
He
together.
gives away his excess apples. How many apples do the two of them together have left?
That would be 48.
Yeah.
Yeah,
Okay, so when he gives away, so together they have 59. Uh, Roll decides to give away his excess. He gives away 11. How many apples do they have left in total? Well, they have 49 together. That's right. They have
59
59,
together, right.
59. They have 59 together.
Right.
Roll gives away 11, and they end up having an equal number.
Right.
Well, you
Right.
don't even have to say they have an equal number here. It's a simpler problem. Roll and Angela have a bunch of apples.
Right.
59 apples. Roll gives away 11. How many apples do you have left?
Yeah, right. That's the right. How many
So
apples
Roll and
do you have
Angela
together?
are,
Right.
you know, you don't have to you don't have to consider them different. You know, they're a team.
Right. That's
The Apple
okay.
team
Yeah, but
has
that
49
right.
apples, 59 apples. They give away 11. How many's left?
Yeah. So then anyone who did the problem themselves, like stopped the video and answered 48, that's the question you answered. So think about that. Think about the difference between the question you answered and what's being asked. A little bit of a tricky question, right? A little. It looks. It's harder than it looks. This is a question that's harder than it looks.
Yeah.
Yeah. Wow. We really did a lot on this one, but that's good. It's really good to talk about this. Okay. Today is Throwback Thursday. All right.
Throwback Thursday.
Here we go. A question from 20 years ago, maybe more, maybe 22 years ago.
Oh.
On hopefully a part of the test types of questions that they don't really ask anymore. So we go back here. We have our thing. We go back. Oh, look, this looks like the one. Yeah, here it is. We marked it with a big brown arrow.
Yeah.
Let's zero in on it. Okay, so you can look at it and stop the video and think about it. And then we will do our best to do it. I'm not a big sequence person. I never really studied this much in school. Seth studied everything in school. He has a PhD in math. Yes, Seth?
Well, no, you have a PhD also.
Oh, that's true. I have, but it's in engineering. So, yeah, but there's a lot of math and engineering. I strongly encourage people to get degrees in math and engineering. They're both great things to major in college. Okay, here we go. So, sequences. Okay, in the increasing sequence above, and I don't know if this is a calculated question, but I don't know if it really matters. Do you want to know? Does everyone want to know? I can't tell. Does it really matter?
No, it doesn't matter.
Yeah. Use of calculator is permitted. Okay, use of calculator is permitted.
All right.
Now, so where are we? Okay, sorry about that delay. Okay, in the increasing sequence above, the first term is y, and the difference between any two consecutive terms is 3. Also known, I think, as the common difference, right? And it looks linear. Difference. What is the value of the fourth term of the sequence? I guess.
We want to find the fourth term of this.
Okay.
Know. Well, first of all, you don't know much about the sequence, other than the difference between two consecutive terms is 3.
True.
So it's so-called arithmetic progression. So let's look at the sequence. Y.
Oh, you do.
Well, hold on.
Do it. No, you do.
Y, 2y plus 7, y plus 6, and then the unknown. So going from here to here, you go up by 3. From here to here, go up by 3. And going from here to here, you go up by 3.
Okay.
Well, if you knew what y was, then you could just, you know what y plus 6 is, you add 3 to it and get the answer. So let's see what we can do. Let's see. So we're saying here, going from y to 2y plus 7 means you go up by 3. So that means in algebra, y plus 3 equals 2y plus 7. Gosh, I could find out what y is.
Yeah, you made it.
So subtract y from both sides, we get y, and then subtract 7 from both sides. So we get 7, subtract y from both sides. 3 minus 7 equals minus 4. So y equals minus 4. So the next term is minus 4. Let's check that. Let's say we do a sanity check. Minus 4 plus 6 is 2. Y we figured out was minus 4. Uh-oh.
No, it's okay. It's okay. Minus
Something's
4.
wrong.
Yeah, no, no, no,
If
no,
y
no.
is
No, it
if
goes
y
up to
is
6.
y is
Fine.
minus 4.
You're fine. You're fine.
No. If y is minus, yeah, okay. If y is minus 4,
you're fine.
Then we have minus 8 plus 7 is minus 1.
Yeah.
Y is minus 4. Add 3. You got minus 1. That checks. Minus 1, add 3, you get 2. That checks. So to get to the next term, what we add 3. 2 plus 3 is the unknown term, which is 5, and we get 5.
Well done. Well done. Well done. So you reached the, what do they call it? The pot of gold in algebra. One equation, one unknown.
Yeah, and in fact, they give the problem. The problem has redundant information.
Mm.
You needed we needed only the first equation. Y first term plus 3 equals the second term. And that gives you one equation. Y plus 3 equals the second term, 2y plus 7. And that has a unique solution. Okay? And so and then they tell you that the term after that is y plus 6. So it's redundant. You know, in other words, we could have solved it by saying 2y plus 7. 2y plus 7, that's this thing, plus 3 equals y plus 6.
Right, and then you could have solved
and you could solve this for y too.
Yeah.
So they might well have made a mistake. So there's in the form of the problem, if they gave a different expression for the third term, if they said, say, y plus 5, then the problem would be faulty.
Right, but they
didn't. Usually, SATs, they do not give faulty problems.
They do.
They're pretty careful about that.
Yeah. Because they have, of course they are. Yeah. Wow, this is great. So you basically turned this question into a one equation, one unknown. Anytime you could turn a problem, any problem in your life, any problem, into a one equation, one unknown problem, that's great because you could solve virtually any of those guys. Or maybe there's a no solution or an infinite solution. But the bottom line is you want one equation. The
strategy of elimination is to, remove one equation and one unknown in each step until you get to the last step when you have one equation and one unknown.
Right. But if you could recant, you didn't have to do it. There really wasn't two equations to unknowns. If you could just write one equation, one unknown, that's the word, the Holy Grail.
Yeah.
The Holy Grail. That's your goal, really.
Yeah.
Wow.
Yeah.
Seth, you did this one really well.
Yeah. But let's say in terms of numbers of equations and unknowns, the data that is the given in the problem. The data is actually two equations in one unknown. The first equation is the first term plus 3 equals the second term.
Right.
That's equation 1.
Right.
Equation 2, second term plus 3 equals the third term.
Yeah, but it comes to
so I wrote the first equation is what's outlined in brown. Right. The second equation is what I wrote up here. And the SAT creators were careful and made those two equations consistent.
Right.
That means the two equations have the same solution.
Right. Right. I'm sure you could write one, and if you write one, you can write one and make it look like the other.
Of course, yeah. If you have two equations like this, the two of them are equal. The two sides are equal. You could add anything to each side and get another equation. Add the same thing to each side, and you'll get another equation. Right. That's true.
When you first look at them, they don't look the same because one of them has a side of 7 plus 3 is 10, and the other side has a 6. And this other one, the difference between 10 and 6 is 4, and the difference between 7 and 3 is 4, right? You got a 10, you got a 10 up here, and you got a 6. There's a difference of 4. As I put froze, you got a 4 here, right? 10 and 4, and then here you got a 7 and 3, which is 4.
I wouldn't go that way. I would just say if you put them both in a canonical form,
hot word.
A canonical form AY equals B.
Okay.
What you'll get is either A and B for the two equations. They to put it into canonical form twice. From this equation you get this. This equation you get this. What's going to happen is if they're consistent, then the A and A prime and B prime must be multiples of one. A common multiple.
Got it. Got it.
And then of course you're doing you're doing this with ordinary numbers, and if the coefficient of y is non-zero, you could put it into even simpler canonical form. The simple canonical form for a non-trivial linear equation in one unknown is simply y equals constant.
Right.
That's an equation.
And that's the answer.
Big deal.
That would be the answer. Yeah.
Yeah. So if you put a single linear equation in one unknown over we mathematicians would call it a field, which means that you could divide by any of the numbers except for 0. There's no complicated canonical form. It's simply Yeah.
Wow. Okay. Congratulations. This is great. Wow. You brought in some extra high level.
But I think in the modern SAT they don't even the concept of sequence, different kinds of sequence, arithmetic, which is an example here is arithmetic is the kind of sequence they do here. It's where there's a common difference between the terms, and then so-called geometric sequence, where there's a common ratio between successive terms.
Right.
Yep. Those are types of sequences they teach to common. The first kind of a regular sequence, first two kinds of regular sequences that are interesting in math. That's covered in some curricula, but I guess they don't cover it. It's not in the new SAT curriculum.
It could be. It could be. The way to know whether it could be is they tell you what's on the new one, but also you go to Khan Academy. And if it's Khan Academy practice, and if it's on Khan Academy practice, then there's a possibility that could be on the SAT.
Yeah.
So, but check the SAT.
But if you go into any kind of use of math and in science, engineering, non-trivial use like finance, anything like that, you're going to deal with both kinds of sequences. Indeed, the geometric sequence is a sequence that pertains to finance. And you have any kind of interest applied to an amount of money, whether you pay it or you receive it, and then you add up various things. All of those things involve interest problems are problems about geometric sequences.
Oh, right, that's right. Then you get into the sums of the geometric sequence.
Yeah, yeah,
Sums,
yeah,
yeah. You get onto all that stuff, right?
yeah.
Yeah. And then each class does it differently because Wow. Okay, so I guess that completes our Throwback Thursday, and may actually complete our SAT math question of the day for the year because we're going to be taking off next week. So then we hope to see you back in January. We'll skip the entire week of December, between now and the end of the year, and we'll get back on January, right, Diddy?
Right,
Yeah.
right.
So
Wow.
we've been doing this virtually every day, every work day since about August 19th, and
Wow.
so this is great, and we'll move on to the next year and continue
Okay,
on.
well, happy New Year's and
Yep.
holidays, and see
That's
you
right.
next year.
Yep. Happy New Year and holidays. Take care, everyone. Bye.
Bye.